Welcome. It's time to talk about new version of Rapise, Rapise 8.3. My colleague Denis and me, Alexei, are going to walk you through new amazing capabilities of this version. As usual, you may access the changelog of Rapise by visiting RapiseDoc.inflector.com, going to Release Notes, and switching to the release notes for this version. It mentions a number of amazing features, and we are going to highlight the most important of them. Let's explore the key highlights of this release. OCR support. Rapise now provides enhanced optical character recognition to improve text recognition and automation accuracy. AutoWait. This feature helps streamline your tests by ensuring elements are ready before actions are performed, making your scripts more reliable. Amazon Bedrock. We are excited to announce integration with Amazon Bedrock, enabling support for advanced Gen AI models, including Claude from Anthropic and AWS Nova models. And modules. Rapise 8.3 comes with powerful, ready-to-use modules, and we are going to touch some of them. RapiseUtils, essentially utilities to simplify automation tasks within Rapise and framework maintenance. AiRobot, designed to support advanced robotic process automation. And AiTester, a module to facilitate AI-driven testing scenarios. So let's delve into details about this release.
The auto-waiting feature in Rapise makes web tests more reliable by checking that web elements are ready before doing anything with them. It was added in Rapise 8.3 and works with Selenium profiles. What does auto-waiting do? Before clicking, typing, or interacting with a web element, auto-waiting makes sure the element is visible on the screen, enabled and ready to use, editable if you need to type text, and not moving and ready to respond to actions. If part of the element is off screen, Rapise will scroll it into view first and then continue the test. Let's see how it works. I have an empty framework with an empty test case. This framework is for testing a web application. So let's record a simple test. I click record on the toolbar. Okay, and now Rapise will prompt me for initial URL. And here I will use the special page that we created to showcase AutoWait feature. This is uitestingplayground.com/AutoWait. So this page is pretty simple. Here you may choose an element. Here you may choose what modification you will do with this element. Then you may click on a button to apply those modifications for a certain amount of time. And then this button will be restored to its initial state. But you can use button or you can use different types of elements here as well. So what I'm going to do here is for now I will just record the click on apply for 5 seconds. And then I will record the click on the button itself. Here we go, and I will delete the section that we don't need. So here I have apply, and here I have button. So, and let's now finish recording of this simple test. Here we go. So what AutoWait means? It means that Rapise should not click on a button until it's not fully visible, enabled, and ready to receive interactions. So we may apply some modifications here, like make it disabled, for example. And then we may run our test. So let's run these 2 steps. place selection, and Rapise should make this button disabled first, and it should wait until the button will become enabled again, and only after that Rapise clicks on it. So before the auto waiting feature, you had to add some sleeps here, like global do sleep to make sure that when we are interacting with the button, it's enabled and ready to use. But with auto wait feature, we don't need this step anymore. So using this page, you may play with different types of controls, and Rapise should intelligently wait for an element to become fully ready for interaction before clicking on it or entering text on it. Auto waiting feature is described in the docs. Let's go to our documentation website, to the release notes, and click on auto wait. And here you may see what states Rapise checks before interacting with the element, and what actions for web elements support auto waiting feature. If you work with an application that contains UI elements invisible through automation interfaces, the last resort is to use OCR. Using OCR global object in Rapise, you may not only extract text, but also determine coordinates of text on a screen and interact with it. Let's see it in action. To demonstrate OCR, I will use the sample test included into Rapise. I am now on the start page. Let's scroll down to the sample section. Here we may search for OCR, and here is our test using OCR. I simply click on it to open in Rapise. Here we go. This sample test contains 3 test cases. One automates Notepad, another calculator, and the third one works with a web application. So let's see what they do. First, I will open Notepad test here, and instead of running it from the beginning till the end, I will run it in parts, so you will see the details. So first of all, let's open the Notepad here, and it will open with some text file inside it. So the second portion of the sample test determines if word wrap is enabled or not, and here you may already see that Rapise is using OCR global object, and what it does, it extracts text from object and it searches for spiral test text in it, and if it is visible, then we consider word wrap is turned on. If not, then we need to use the menu to reveal it. So let me turn off word wrap. So here you may see that spiral test text is not visible, and I can run this part, and we will see that Rapise will go to format and will choose word wrap. Okay, so let's proceed with our test. Here again we use to extract from object OCR action, and then Rapise tries to click inside the text editor first on Angular version text, and then it looks for help string in the application window and clicks on it. So let's see what we will have. I am expecting Rapise to click on Angular somewhere here. Here we go, and we can see that Angular is selected. This is the cursor. And the last thing to run here is clicking on the help. So here I may interact with the menu item. So this thing works. Let's find our OCR object. So it's inside global object section, and you may expand it and see what actions you may use. You may click on text in the object inside the window. You may extract text from various sources, from image, from object, from screen. So this is, if you want to figure out what parameters you need to pass to an action, you may press F1, and Rapise will show you the description of the API of this section. This is built-in help inside Rapise. Alternatively, you may go to help, online help, and here you may search for OCR and find it here, and you will find the most recent online version of the help file. Okay, so let's proceed to the next test case here. The second test case is HTML test. So let's double click it here. It's a bit more sophisticated. It opens the browser. So, and then it clicks in different places on the text inside the text area element, and it does different types of clicks. First, it should do left click, left double click on Angular version text somewhere in this area, and then right click on not a real application text. And then it verifies that text contains specific string, and then it also should click on a value inside input text. So let's run it. I can actually run the whole sheet here. Rapise should open the browser, open the page, and then scroll to the text area element, type some text, and here we can see that Rapise clicked in the middle of Angular version, right click, not real application, and then clicked on the text input, and then closed the browser. So this is how OCR works, pretty simple.
Inflectra is further strengthening its integration with Amazon Web Services by adding support for generative AI models available through Amazon Web Services Bedrock. This includes models from Amazon Nova series and models from Anthropic. Notably, one of the Claude Sonnet v2 models features a unique computer use capability, and Rapise is fully equipped to support it. We will demonstrate it later in this video. Setting up connection to Bedrock is straightforward. You need to go to AI Dashboard through View AI Dashboard, switch to Settings, make sure you have provider chosen as Amazon Bedrock, specify region, specify the model ID. For some models, like Anthropic, you need to specify inference profile ID, as shown here. You may get this ID from the model description card. Then you need your AWS access key and secret key. If everything is filled correctly, doing test model will show you successful result. To summarize everything, this is the information you need to configure connection to Amazon Bedrock. Region, key, secret, and model ID or inference profile ID depending on the model. There are new public modules that utilize new features of Rapise 8.3. Let's go through them. The first module worth mentioning is RapiseUtils. It contains some methods and entry points for maintaining the testing framework. Here we have a new empty framework for which we want to import some manual test cases. I'm right-clicking on Modules Pages node and choosing Import Public Module, RapiseUtils. If I expand it, as you can see, there are a number of methods, and all of them are intended for maintenance tasks for the testing framework, cleaning the AI command cache, converting AI command from separate format to consolidated format to reduce the number of files, and finally do import manual. This one we are going to use right now. Let's just go ahead and try using it. Right click on do import manual and choose invoke do import manual. It starts doing something, and first thing it shows is the picker to asking to select the test case folder from Spira. I'm trying to select something, choosing load folder, and it fails. It fails with the message that this framework must be synchronized with Spira first. So we need to use Spira dashboard and save it. So I'm going to synchronize it with Spira in the usual way. Accepting everything, answering everything, pressing OK. And waiting for the synchronization to complete. It is done. Now closing the dashboard and trying to invoke do import manual again. Again the same prompt, again choosing the folder and pressing load folder. Now you may see that some animation starts, so it starts populating the testing framework in Rapise. For each test case that were in Spira, we now have a test case here. And since it was manual test cases, we have manual steps node for each of them. Now let's open this manual steps node for some test case and see that test case contents are shown now. So we may use the AI button to convert these manual steps into AI steps, which is the closest counterpart for manual. So now we have AI test that is supposed to be automated by using standard AI command. Since it's a new framework, it have no information about the application under test, about library information system, and I have a few options here. Either I may learn some objects, or I may use AiRobot, and we will talk about this a bit later, or I may use page objects if I have some available. In this case, I have some automated testing framework for this application, so I may reuse some page object. I'm going to use import page object. I have a testing framework for library information system. It had some page object, so I'm going to import it. It's called PO common, page object common, and it has some common entry points for interacting with the application, like doing login, adding a book, and so on and so forth. So those are now maybe reused by the AI generator. So in the RVL, in the generated test, I may press AI button now and press generate all, in the hope that it would be able to capture needed information and apply it to the library information system scenario. So for the first one, it is trying to call login to application SS test, which is here. and we did not import it. But if we import this test case, it is also part of the testing framework. This would start working because it's invoking the test case and passing some parameters to it. Then it tries to use PO command whenever possible. So it's using it to create an author, add a book, and so on. It fails to find some controls like create author link, because the instruction says click link to create an author, and we don't have like page object to do so. And it fails to do submit. It supposes that I have submit button. So I have two options here. Either I may learn missing objects, like create author link, that's possible, or I can update this page object to include corresponding action. Anyway, majority of this test case is already automated, and I just as close as possible to automating it completely with the help of AI and with the help of Rapise. Once I accomplished everything and once my test case is working, I may mark it as ready. So I do shift and right click. So if I right click without shift, there is no text context menu. If I click shift, there are text context menu where I may untick the draft node, and my test case becomes ready to use. This one is not yet ready to use. I'm marking it as back as draft. So this is one of the ways of conversion from manual test case to AI command. And I'm going to demonstrate you AiRobot that enables even deeper conversion possibilities for the same scenario. Let's summarize the new capabilities that we got through the use of RapiseUtils. First of all, RapiseUtils contains some things that are intended to maintain your testing frameworks, cleaning something up, updating something, or as I just shown, importing manual test cases into Rapise, also importing manual test steps, and preparing it to convert using the AI command. And this piece, this chunk, may be considered as a part of the chain where you have requirements in Spira, you convert them to test cases and test steps, and then you may automate these test steps using this DoImportManual feature that I just shown. So you have end-to-end process from requirements to automated test cases. Next interesting use case is AiRobot page object that is intended to do interaction with the application based only on instructions. No objects, no page objects, no object repository, no express, nothing. You just say what you want, it looks at the screen and tries to do what you want. It requires to use Claude Sonnet v2 model with computer use feature enabled. This model is available through AWS Bedrock, and we were already talking about how to configure it. Also, we have a number of video tutorials regarding AiRobot, so if you are going to use what I'm going to show you, just follow other videos and learn more about this functionality. Long story short, with AiRobot, all I need to do is to open the application and make its size something reasonable for AiRobot, not too big, not too huge. And after that, I just need to say what I wanted to do. I just saying login as librarian. No object, no XPath, nothing. Just saying that and it would log in. Then I'm saying change the genre of the book with name the sign of the 4 to detective fiction. It would go to the books module, it would open it, it would edit it, it would save it and check that result is matching what we wanted to see. Long story short, I've just executed this test And the first step was to log in, and robot managed to log in, and I may see that this is the screen, welcome screen after login, and it says that I've successfully logged in as librarian. And then I may see the results of book editing. So this is the list of the book, my book, the sign of the 4, and it's genre now detective fiction. So in this short report, I may see the results. I may change the verbose label to like 3, and in this case, the execution will trace each mouse click, each intermediate screenshot, and so on. In this case, it's short. And only one thing worth mentioning is the time of the execution. It's about 10 minutes. So if you execute it manually, it would take maybe definitely less than a minute for the same. And if you execute it automatically, it may fit in something like 10 seconds for the same scenario. So robot is slow, but it's completely automatic and requires minimal preparations to execute.
Let's look at AiTester. It can count objects on the screen and answer general questions about what it sees, making it ideal for content recognition. While it's similar to OCR, AiTester does not provide screen coordinates, so it's best for understanding content, not positional tasks. It also consumes AI tokens, so plan usage accordingly. AiTester lets you send text and image-based questions to AI and get smart text answers. It's great for tasks like image comparison, so you may detect visual discrepancies like layout shifts or missing elements. Do image analysis, analyze images to count elements or validate patterns. Perform text queries, for example, generate data or answer questions with AI-driven text output. And do text-based assertions, validate extracted text or application states dynamically. Let's start by installing AiTester. First, open your testing framework and then right-click Modules and Pages node in the object tree. Then go to Import Public Page Object. Wait a bit until the list of available public page objects appears, and then choose AiTester. It will take a while to install, and after that, if you will expand Modules and Pages node, you will see AiTester there. So you may read its description, and you may expand it and see what actions it brings to your testing framework. So let's see it in action. I will expand Test Cases node and will navigate to AiTester. By the way, this testing framework that I'm showing you right now, it's available on GitHub. Just go to Inflectra GitHub realm and there find Rapise Power Pack section. So let's go to GitHub and let's go to Rapise Power Pack. So you may clone all this repository, or you may find FW useful page objects and just download this part of the repository. And it contains exactly the same framework that I'm showing you right now. So let's open one of test cases here, AiTester Web. Actually, to start using AiTester, first thing that you need to do is to configure AI. So I will go to View, AI Dashboard, and here I will go to Settings. Here you may choose between AI providers, and then for each provider that you will use, you will need to specify some information like model name or API key or anything else. So, for example, for OpenAI, you may specify an environment variable with an API key. So this is why I don't have it here. So let's test model and see if Rapise can connect to it. Okay, it works. It means that AiTester is ready to use. So let's close the dashboard. So here I have a demo that compares two variants of the same website or the same web application written using different technologies. One is built with Angular UI and another is built with React UI. So what we have here is Rapise will open the first variant, will remember its screenshot, will open the second variant and will remember its screenshot, and then it will do multi-image query to compare the images that we have here on the stack. So we need to know what is different between the images. So let's run this piece. I will do play this sheet. So Rapise should open the browser, Chrome, and first we will see the Angular version. Here it is, and then React. And then information is sent to AI, and let's see what we got from AI, what response we have. So here in the report, I have my two screenshots, and this is the response from AI. So it spotted that these actually applications are a bit different. The second one contains books and authors links, and also it contains check this out section with additional links. So we have some information about differences between these images. So let's take a look at another example. So here I have another test case, AiTester desktop. Let's scroll it down, and here what it does, it has two images, and it also puts them on stack, and multi-image query will use all the images from stack and will try to find differences. So let's take a look at our images. So they are here in shared section. So this is the baseline and this is the new version. So we have two kids puzzles and we need to find the differences between them. So let's run these 3 steps and see what AI will find. So I do play selection. We will not see anything changing on the screen, but we will see the response from AI here. So it actually spotted that cloud number changed. Also, there is a butterfly instead of a bee, and here it didn't find the sun face. So some of these differences are meaningful, some of them are not, but we got some differences from AI. We may probably refine our query and get more precise differences between these two images. So what else we can do with the AiTester? Let's return back to AiTester web test case and go to RVL sheet here. So besides image queries, AiTester can also do just text query. So for example, I want to generate a random string of 10 alphanumeric characters. So let's run this piece, play selection, and in the report we will see the generated value. So it will be placed into last result variable, and in our test case we can use it somehow. Also, let's send some generic query like how many days we have in the next year, 2025. So we get the result. So what else we can do? We can also use some workflows defined in AI settings in Rapise. Again, if we will go to AI dashboard and we'll try to create a new chat, here we will see the available workflows, and we can use name of each of these workflow to query AI. So let's cancel this and let's generate 5 A company names using generate data list workflow. And let's see what we will get in response. here we go. So here we have the list of companies generated by AI. What else we can do? Also, we can do some high-level assertions about the page. So, for example, is user successfully logged into the application? So let's run these two lines. We are not logged into application, so in this case, we should get something like no or false. By the way, let's log in into the application and try to figure out, run this again. So this is the live demo. This is why something can go wrong. Okay, so we have true in response. It means that AI detected that we are logged into application. What else we can do? Let's log out and count how many input fields do we have. I will call just this step, and I hope we will get 2 as a response. Yes, we have 2 input fields. Besides these queries, you can do assertions using AiTester. It can do soft assertions or hard assertions. It works the way that this assertion action just receives the text and some hypothesis it should test against this text. So, for example, let's run this part. It will navigate to a page where we have something bad in the layout. So here you may see that the name field is partially overlapped by some other control. So let's run this assertion does this page look okay? And I hope that in the response, AI will say that there is some overlap problem. And then we will assert this last response, if the page is okay or not. So let's play selection. AI runs the query. And here what we've got in the response. The page does not look okay because name input field is overlapped by gray box. And then when we send this text to AI together with this assertion, the page is okay, we get false in response. So the page is not okay because the name input field is overlapped by some gray box. Let's see what else we can do with AI. So we can do things like OCR. So for example, here I have a desktop test. So let's run Notepad here. And here we have it. And it has some menu items. Let's go to AiTester desktop. And here we will ask it to list items in the menu. So app here, actually this is the control that I learned here, and this is the whole application window. So let's run this part, play selection, and in return we should get the list, comma separated list of the menu items here. Here we go. This is the result that we expected to have. Also, again, here we may send a query and count the number of menu items. We can do query against the window, and the Rapise can find the window by title. Also, we can do full screen query if some application is running, and you may invent some other queries as well. So when you do full screen query, Rapise captures the whole screen and sends it to AI. So you can do a lot of different things using AI and AiTester. since AiTester can send a number of images and the text query to AI and get the response. Let's summarize. With AiTester, we are bringing the power of AI right into your automated test cases. Whether it's catching those sneaky layout shifts, spotting missing elements, generating random test data, or handling complex checks, AiTesters got you covered. What makes it truly special is its adaptability. It works like a super observant tester, but with the speed and reliability of automation. Thank you for joining this demo.
All three OCR, AiTester, and AiRobot features that were mentioned in today's video may be combined together as the features related to computer vision capabilities. So it's worth to compare them. And the first aspect of comparison is speed, where OCR and AiTester perform much faster compared to AiRobot. Next aspect is the free text query, where we may ask arbitrary information from what's visible on the screen. Is it positioned properly? Are there any visual bugs? How many of something you may see on the screen, and so on. So both AI tools may do this, and OCR cannot do this. It can only extract text from the screen. Next is runtime token cost, where both AI tools spend some tokens and robot spends much more tokens for execution, while OCR works completely locally, so it's free and no tokens are used for execution. Next feature is screen coordinates. So is it able to detect something on the screen that we, for example, may want to click at? And both OCR and AiRobot can do this, while AiTester cannot do this. So it may answer how many buttons on the screen or if button is available on the screen, but it's unable to detect the position of this button that we may use in the automation. And final aspect is exploratory testing. So only AiRobot is able to do this, where we providing it with high level requirement of what we want to do, and it's moving on and trying to achieve its goal. So I hope this helps to set up the layout between these three capabilities. Here is a quick summary of key features in Rapise 8.3. Computer vision. We introduced powerful capabilities like OCR, AiTester, and AiRobot to enhance visual recognition and automate complex visual tasks. Web automation. The new AutoWait feature makes your test execution smoother and more reliable by ensuring that web elements are ready before interacting with them. AI provider added, and it is as amazing as Amazon Bedrock, enabling seamless integration with advanced generative AI models, including AWS Nova and Anthropic Cloud. Finally, manual testing conversion were pumped up through the RapiseUtils. This module simplifies the transition from manual to automated testing, helping you accelerate your testing workflows. These enhancements ensure that Rapise 8.3 is smarter and more efficient and ready to take your automation to the next level. You will find the links to video tutorials for AiTester and AiRobot in the comment for this video. Thank you for watching and have a great day.